Hello students, welcome to the chemistry sessions. I hope everybody is doing great. So, are you enjoying the techniques that we are doing? In the last session we had started off with, yes, crystallization. We had discussed crystallization and recrystallization along with the simple distillation. So, I hope everybody has revised all the concepts. So, what we were doing in the simple distillation? Before moving on to that, I'll just write down what all techniques we have covered. We have covered the sublimation, right? I hope everybody remembers this. We have covered the crystallization in the last session. Crystallization. Right? What else? Recrystallization, also known as recrystallization. Clear? And what else? We had started off with a very simple procedure, that is of distillation. So I have got a simple one. So I have got a simple distillation. I have got what kind of distillation? I hope everybody has read it or not. So every time whenever I give you homework, you need to go through the concept first, because that would be pretty easier for you to then follow up the session. So here simple distillation we have got fractional distillation. Right? Distillation. Every time I am writing down the incorrect spelling, what else we have got? We have got reduced pressure. It's very interesting technique. Reduced pressure distillation. And the last one is what kind of distillation? The steam distillation, also very popular. So as we had discussed about the simple distillation in the last session. So what actually the simple distillation is? We just boil off the mixture of compounds which are having. So here main thing is the boiling point difference must be sufficient enough. Must be enough. That is around 50 to 70 Kelvin. An approximate value I am telling you about. So that is the minimum kind of boiling point difference that must be there. Why there must be a difference in the boiling points? Because if the boiling points are nearby or closer to each other, and we have taken up, let's just say we have got a round bottom flask here, and we take up the mixture, let's say of compounds A and B. One is having, let's just say, a boiling point of 105 degrees Celsius, and other one is having, let's say, 115 degrees Celsius. So what is the possibility over here? The possibility is, if we try to boil off the compounds, they might be boiling off together, and there will be no use of then this technique, because it won't be separated. We'll be getting a vapors which is a mixture of the two again. So again we are back to square one, we are back to the same position. Again we need to separate it out via some other technique. So that is why we need compounds which are having a difference in the boiling point. And what are those compounds? Can you give me an example? So it's ether and toluene, that is also a mixture. They have got sufficient enough difference of boiling points. So ether and toluene, I have got hexane and toluene. And also I have got a very popular mixture, that is of chloroform and aniline. So that is also mixture which is separated. So these are some kind of mixtures which are actually separated via this technique, because these mixtures have got sufficient enough difference between the boiling points. So I hope everybody is clear with the fact. Now let's just move on to the fractional distillation. We are through with the simple one. So let's just move on to the fractional. So again we will be drawing the structure first, we will be drawing the apparatus first, then I will explain you. So what is actually the fractional distillation? In fractional distillation, so basically what we do is we actually put a fractionating column. Fractionating column, we have got a similar kind of an apparatus, that is we take up RB, that is the round bottom flask. What else we take up? We take up a wire gauze on which it's kept, right? So that is the wire gauze on which the RB has been kept. Clear? What else we have got? We have got a tripod stand. So here we have got a stand like that and a burner. So we have got a burner also. So that is how the burner would be. So just draw with me simultaneously so that you have a practice of it. So a similar kind of procedure we are following up. And what else? Now here comes the fire. We light it up. So that is the fire. That is the flame we have got. And what else we have? We have the RB, and the RB has got a mixture of compounds. Clear? So it has got a mixture of compounds. So here is the liquid that we have taken up. Fine, here is the liquid. Again what do we have? We have got a stop cork. We have got a stop cork over here. It's always orangish in color, orangish red, even if you see these in laboratories. So that is stop cork. Clear? And what else? We have got a tube which is penetrating inside the cork and then going inside the round bottom flask. So that is RB. We name it as RB flask, nothing but the round bottom flask. What will happen? There is a tube inserted in here, but not a tube exactly over here. What is the difference between the simple distillation and the fractional? Now we will see here. So here we have got is a column. We have got a column over here. That is the column. This is the column over here. And here it's again a stop cork over here. The column has got something in it. Let us just see what is that. So it has got some beads in it, some crystals in it. So these are the kind of beads which are present, which are actually what the beads are doing whenever the liquid boils off. So whenever the liquid boils up from the round bottom flask, it goes into the fractionating column. It has got so many kinds of glass beads that the surface area or the travelling time of that vapor increases. And that means what? Those kind of liquids which are having the closer boiling points will actually be separated very efficiently via this technique. So what is happening here is, Let me just draw some more glass beads over here. Now that is how the glass beads are. So these are glass beads, increasing the surface area basically. What will happen? The liquid will then again boil off. Goes into the condenser, gets condensed, and finally into some kind of container we have got. So what is that container? That container will look like somehow like this. It may be a conical flask that we can take up like that. So that is how the conical flask would be. So that is the conical flask we have got. And what else? We have got the pure liquid. What are we missing out? We are missing out the condenser part, right? So just try to draw the condenser along with me. The condenser has got an inlet and an outlet. So that is the inlet and that is the outlet. Clear? Now what does the procedure say? Here also what we are missing out again is a thermometer. A thermometer is also kept over here along with the fractionating column. We have got, I am just making because there is not enough space, so I am just making the thermometer like that. So that is a thermometer. Fine, that is the water condenser. So always and always mark the things. So we have got a mixture of compounds over here, mixture of compounds, and that too, let's just say A and B. The difference between the boiling points in the mixture of compounds here in the case of fractional distillation is approximately 10 to 30 kelvins, not more than that. So here the boiling points are closer. So that is boiling point difference between the two. That means the boiling points are closer to each other. Clear? Fine. So that is the entire technique over here. What do we do? Let us just discuss that. I hope everybody has drawn it out. Now we have got a round bottom flask. In round bottom flask we take up the mixture of the compounds that we need to boil off, that we need to separate. What we are doing is the purification technique. We are separating out the compounds with purity. So we obtain pure compounds over here in this technique as well. If any kind of impurities is present, that will remain as it is in the RB flask. So that is what it is. So we take up a mixture. Here, not in the case of simple distillation. In simple distillation, we had taken up the boiling points which are the boiling point difference which is quite large, because we need to separate it out the liquids one by one. We do not have any kind of source other than that. Over here I have got a source. What kind of a source we have? We have got a fractionating column. Fractionating column. Clear? And this column, what it does is, whenever the liquid gets heated up like that, it moves into this fractionating column. It travels so long that the temperature keeps on rising in the RB flask. So what happens is, first of all, if I just assume that the boiling point of A is greater than boiling point of B. right? So which will boil off first? The one having the lower boiling point, so this one. So it will boil off first, the B will be travelling and travelling in the fractionating column slowly and slowly. The procedure is very slow. So it just travels and travels till the time what happens is the temperature here rises so much that A starts boiling off. And when the A starts boiling off, the B has almost reached at the top. So B has got time to travel up and then gets condensed before mixing with the vapors of A, right? So we are actually increasing the traveling time, we are actually increasing the surface area. So here the surface area is increased, the traveling time is increased, and when it reaches the top, when the B reaches the top, it gets enough temperature, it gets enough time for the A to boil off. Finally, the B condenses off first, and then gets collected over here. And again, what happens then? A will start boiling off after some time. So it will boil off and then gets collected. So that is how the different liquids get collected. And since the liquids are actually having a very less difference of temperatures of boiling points, so we cannot use a simple distillation method because that would give us both the mixtures of pure liquids. So we don't want that, we want a separate one. So here that is how the separation technique is. And not only these type of columns, we have got different kind of columns. So a column could be like this as well. So we have got different kinds of formations like this. That is how one column could be. We need to just provide the enough surface area, we need to just provide the enough timing to travel. So that is how our main motive is in order to separate. So that is how the different kinds of columns look like. There are hundreds and hundreds of columns available in the market which has got different kind of structures, different kind of shapes present in, just in order to have a different kind of attainments, different kinds of organic compounds attained. So depending upon the criteria, depending upon the type of organic compound we want to obtain, we use different kind of columns. We can choose different kind of columns. Also there are such columns which are having bulbs like that. So that is also a column. So these are the bulbs. So these are the different shapes of the columns. And I hope everybody has got the procedure what we have done. So we have just boiled off, and till the time the B rises, the B gets collected over here. It first condenses, then A will come up. That is how the procedure is. I hope everybody is clear with the fact. We are through with the fractional distillation as well. What is and where is this technique used? So fractional distillation most commonly is used whenever we are separating. Remember the procedure of pyrolysis, you must have done this in lower classes, pyrolysis and the breakdown of the crude oil into different kinds of oils, that means kerosene, paraffin, wax and diesel, petrol, whatever it is. So there are so many kinds of gradations in crude oil, we can obtain so many kinds of oils from the crude oil. The procedure involves a fractionating column. A fractionating column just as we have done this here, but quite a bigger one, something like this you can say. So this column is so big that it has got so many inlets over here. So depending upon the boiling points, the liquids will boil off and then condense from different outlets, and the different outlets actually attain or obtain different kind of oils then. So that is used there. It is, so let me just write over here, fractional distillation used in separation of different products, from crude oil. You must have recalled the concept, that is the cracking of hydrocarbons. So yes, so we have done this already. So I hope everybody is clear with the idea. Now let's move on to the next one. What is the next one? Is the reduced pressure distillation. What is reduced pressure distillation? This particular distillation is actually used whenever we are having so much of high boiling point for a compound that we cannot just heat the RB and then obtain it. So in order to that, what we do is we reduce the pressure of the liquid on the surface of the liquid and it boils off. That means we are in turn reducing the boiling point. So here is the technique. The distillation technique most suited for separating glycerol from spent lye in the soap industry is. So first of all, let us just analyze what the question says. So they are asking about some kind of distillation technique, and what we have done so far is different kind of distillation techniques which are given over here. So suited for separating. Now we need to separate glycerol from the spent lye. What is this particular thing? Glycerol from the spent lye is basically nothing but the saponification reaction. And the spent lye is basically what? This spent lye is the alkaline glycerol. What is this alkaline glycerol? When the fat is converted into, saponified into what? Saponificated into the glycerol along with the soap naturally. So what is left in the mixture is glycerol along with the soap, that is alkaline mixture of both, that is known as the spent lye. So we need to separate it out and we need to take out the glycerol as a whole. So for that purpose, if I go for the simple distillation, so that would be a cumbersome process because simple distillation would be requiring lesser temperatures. But if we go on to the boiling point of glycerol, so I would like to tell you over here, the boiling point of glycerol is approximately 290 degrees Celsius, right? Which is quite high. So simple distillation will be unable to achieve this much of temperature easily. If I go by fractional distillation, again it would be a very improper method. Steam distillation if I go, so steam distillation also, it must be having some immiscibility with the steam, with the water, and that is not possible over here because glycerol is soluble in water, right? So here all of these three methods will be wrong, but distillation under reduced pressure, which will actually reduce the boiling point of the glycerol, and now glycerol can easily boil off, easily separated. So that is what the answer over here is. Distillation under the reduced pressure. So we need to reduce the pressure of the entire reaction mixture, reducing the boiling point of the glycerol and separating it out. Clear? So answer is D over here. Let's move on to the next question. Very next question. What does it say? A miscible mixture of benzene and chloroform can be separated by, so I have given a lot many techniques here. So let us just analyze first what benzene is. Benzene is a non-polar compound, right? Whereas chloroform will be polar. But they are saying over here is a miscible mixture they have taken. That means they have taken both of them in such a quantity that they are miscible with each other. So there is no point of sublimation because sublimation is solid to vapor conversion, right? So here both of the things are in liquid state. Chromatography, again we are not sure about what kind of adsorption will be there on the stationary phase. Crystallization, what is crystallization? We need to first dissolve it into some solvent, but these are itself liquids. So how can that be possible? And now comes up the distillation, and also I would like to tell you a point over here in crystallization is, if I have got a liquid only and then I boil off, then I heat it out with some kind of solvent, what will happen? If I then try to cool it down, again I will be getting the liquid and not the crystals. So the condition for crystallization is we must be having what? A boiling, a melting point, right? Melting point higher than the room temperature, right? So that is how we can obtain some crystals at room temperature for that substance. So this crystallization is also not applicable, because here both of them are liquids. Benzene is a liquid and chloroform is also a liquid at room temperature. Now comes up the distillation. So if I look at the boiling points, boiling points of benzene, so it will be around 80 degrees Celsius, whereas for the chloroform it's around 60 degrees Celsius. So there is a difference of 20 degrees Celsius boiling points. So right, we can apply, we can take out the method of distillation for the separation, and to be very precise, I can also use the method for fractional distillation, because the two boiling points are closely related, right. So I can have, to be very precise, steam distillation, not the steam but the fractional distillation over here, and thereby the correct answer is D. I hope everybody has got it. Which of the following compounds gives blood red coloration when its lysines extract is treated with alkali and ferric chloride, right? So again, the question for lysines extract, a very famous lysines extract, an organic compound, an organic solution that is used to detect the various elements present in the organic compound, right? So they are asking about when are we getting the blood red coloration when the lysine extract is treated with alkali and ferric chloride. So basically for this particular question, you need to have a proper knowledge about what all reactions are happening. So I've got the Le, right? I need to react it with alkali and then ferric chloride. So how do we get the blood red coloration? That is the question over here. So the blood red coloration, how it's get observed is, the Le should be in the form of, first of all, NaSCN, right? Sodium thiocyanide. So that is the Le which is need to be there, and when this Le reacts with Fe3 plus ions, it will give what? It will give the blood red coloration. Now what is the compound which is formed? So that is the compound which is formed, which actually is responsible for the blood red coloration into the solution. So that is blood red coloration, right? So what we need over here is, in this particular reaction, we need to form SCN, that is thiocyanide, and for this SCN we need to have S, C and N, all the three elements present in the reaction site, right? So out of these four options, what is the answer? So first of all, if I consider thiourea, you need to have a proper information about what is the structure of all of these compounds. Thiourea looks like this. Next is diphenyl sulfide. So I hope everybody knows what diphenyl sulfide is. If not, you can just very easily form the formula. So that is the structural formula for it. Diphenyl hydrazine. If you just look here very carefully, in diphenyl hydrazine as well, you will not find any sulfur present over here, right? So there is no sulfur present, right? In benzamide as well, no sulfur. Over here sulfur is present but nitrogen is not present, so no nitrogen, and it is the only A option in which nitrogen, carbon as well as the sulfur is present. That is what we need in the particular reaction getting the blood red coloration. So we need sulfur, carbon and nitrogen. Whenever a question pops up about what all compounds will give the blood red coloration, you need to just see which compound contains all the three, that is sulfur, carbon and nitrogen. That is the important thing over here. I hope everybody now remembers it. A is the correct option. Now let's move on to the next question. So what does the next question say? Okay, now it's the multiple type question. Multiple choice, sodium fusion extract obtained from aniline. What is sodium fusion extract? That is Le, Lassane's extract. Obtained from the aniline on treatment with iron sulfate and sulfuric acid in the presence of air gives Prussian blue. Prussian blue color. Again, it will remind you of what? The test for the nitrogen, right? That is the detection test for nitrogen where we get the Prussian blue color. Hence, the blue color is due to the formation of. You need to have a proper knowledge about what all reaction is going on. But as you can see, it's a multiple choice question. So, we need to be very careful while choosing our choices, right? So, first of all, let us just have the reaction related to it. So, the reaction is, if I get Cn negative, that is from the Le. NaCN, right? What was the Le initially taken? NaCN. It reacts with Fe plus 2 ions, right? That is coming from the ferrous sulfate. And what we get is this is hexacyanoferrate. So, this is what we get. We are not complete yet. Next is, when due to the presence of this sulfuric acid, it converts most of the Fe2 plus ions into Fe3 plus. So, those also react with the compound which is formed. 4 negative plus what? Fe plus 3 ions giving the compound, that is Fe4 Fe CN6 whole thrice. So, that is what we are getting. Ferrocyanide, right? Ferri stands for the ferric over here, ferro stands for the ferrous over here, right? And we need to look for this particular option. So, if you look for this particular option, I will be getting only one as my answer, that is A. If you go by the other options, Fe plus 3, let us just check because this is a multiple choice question. So, Fe3 plus, over here if this is Fe3 plus, right, that means this will be ferrous because this is 2, the counter ion is 2. By the cross multiplication method, I have found out that this is plus 2. This cannot be the case. Again by the cross multiplication, plus 2. Again cannot be the case, and by cross multiplication, yes, this is plus 3, but this would be 3 minus, which is not at all formed in the reaction mixture. So, this particular this question appeared in the multiple choice question, but that is just to confuse you, because some of the students might think that there will be multiple answers going on over here. So, they may mark one or maybe more than one options. That would make your answer completely incorrect. So, you need to be very careful while choosing the options. This has got only one answer right, right? So, that is A, we have got it already. So, I hope everybody is clear with it. So, it is not necessary that each and every multiple choice question will be having multiple answers. So, you need to be very careful. Next question says, okay, now it is the comprehension type question. What is the passage over here? During the detection of elements by Lassane's test, again the Lassane extract question, the covalent compounds are converted into ionic compounds by fusion with metallic sodium, right? They have told us the process of what all process is happening in the Lassane's test, right? The nitrogen, sulfur and the halogens present in the organic compound. These are the detection of elements via Lassane's test, right? So, in the organic compound are converted into cyanides, sulfides and halides respectively. We all know that, which are then detected by their usual tests. So, that is, they have given just an information about how the Lassane's extract is formed and what is the use of this Lassane's extract. I hope everybody gets that. Now, let us just check the questions. Based on it, an organic compound containing NCO as an extra element is fused with the sodium metal and then extracted with water. the species which is not present in the solution of the extract. So, I have got nitrogen, let me just rub that. I have got nitrogen, I have got sulfur, I have got oxygen, fused it with Na, what all do we get? NaCN, Na2S, right? We all know what all are the formations, and for oxygen there is no such kind of an interaction with the sodium. So, then these are extracted with the water. I have got an alkali as well, right? The species which is not present in the solution extract. Now, the solution extract we have formed. So, these are the species which can be formed over here. I can have CN, right? I can have CNS, right? I can have sulfide, but nitrate cannot get formed over here. So, that is, there is no such possibility of formation of nitrate. This can be possible if the sulfur gets hindered with the nitrogen. So, in that case we get NaCNS, right? In that case we get this. Otherwise, we can just get the sulfide, right? And there is no chance of formation of nitrate here, right? So, that is the option right. So, I hope everybody has got it. Answer number C is the correct one. Clear? We have ruled out all the other possibilities.